Hi everyone, this video is going to be similar to the last one. We're still working with the same SOL, graphing linear equations, but this time we're going to have a specified domain that we need to use. So what we practiced in the last video was graphing an equation. If we were given y plus 3x equals -2, the first thing we would do is rewrite that in function form. So we would subtract 3x from both sides to get y equals -3x minus 2. And then from there we would fill in a table of values. So I chose those 5 x values, plugged them into the equation, and then solved for y. So once I got the range, the y values, I then had all the points to graph. So I graphed those points and then connected those points with a nice straight line with an arrow on either end. So that's what we worked on in the last video. What if we have something like this though? Graph the function y equals -1/2 x plus 4 with domain x is greater than or equal to 0. Then identify the range of the function. So this looks a little bit differently because it's telling us a specific domain we need to use. We follow the same exact steps to graph this. We just have to pick the x values carefully. So let's start graphing this example to show you what I mean. My first step would be to make a table. So when I make a table, notice my x values are either 0 or bigger than 0 because of that specification the problem gave us. So now that we have the x values, go ahead and pause the video and solve for those y values. Go ahead and check your y values against mine to make sure your points are correct. And now we're going to follow the same next step and we're going to plot those points. So I plotted those 5 points. And you may start realizing that my graph looks a little bit different than normal. When I connected the dots, I connected the points with a ray because of that restricted domain. X isn't allowed to be less than 0, so I can't have my line, I can't have any part of my graph on the left side of 0. So we just start at that y-axis when x is 0, and then we form a ray. We connect all the points, and then on that end we have an arrow, because x is allowed to be anything positive. Now to answer the other question, identify the range of the function, well, I'm going to consider where the y values are, where the y coordinates are of these points. So I can see that the highest point I have is right here. That point is 0, 4. So this is the tallest, the highest, or the greatest y value I have on my graph. And I see that the y value, as we move down the ray, gets lower and lower and lower. So I can say that my range is y is less than or equal to 4. We start at 4, and then we move all the way down. Go ahead and try this example on your own. We're given the function y equals -3x plus 1. The domain is x is less than or equal to 0. After you graph it, identify the range of the function. So pause the video and then check your answer with mine. Okay, so when I made my table of values, I chose the points -4, -3, -2, -1, and 0. Yours might be slightly different than mine, but just make sure you have no point greater than 0 for your x value. I then graphed those points on the line. So you can tell I have a ray again here because I can't have any part of my graph being to the right of that y-axis. And it can't be to the right of the y-axis because that's where x is equal to 0. Now I'm identifying the range. Well, I see that my lowest point is right here, and that's at the point 0, 1. So my range starts at 1 and then goes higher and higher and higher as it's moving to the left. So that is how I got y is greater than or equal to 1. Here's a word problem. Go ahead and read this to yourself as I read it loud. The distance d that a runner travels is given by the function d equals 6t, where t is the time spent running. The runner plans to go for a 1.5-hour run. Graph the function and identify its domain and range. Well, the first thing I want to do is I want to identify whether the problem has a specific domain or range in it. Well, it says that the runner plans to go for a 1.5-hour run. So right away, I know that my domain is going to be between 0 and 1.5. The time is allowed to equal both of those. So we have 0 is less than or equal to t, which is less than or equal to 1.5. Now we're going to graph the function. I made a table of values. I counted by 0.5s or by halves. So I started with 0 and went all the way to 1.5. I plugged in those values, and then I got those answers for D or for the y-axis. So when I went to go plot those points, notice this time I'm not getting a ray, I'm getting a line segment, because my domain was specified at 0 and it was specified at 1.5. It can't go beyond either of those. So this line segment, it's not going to have any arrows on it because it needs to stay between those two numbers. And then finally, we need to look at the range. Well, I see my lowest point is right here on the graph. The highest point is right here. So I see that that y value, or distance in this case, is between 0 and 9. And that is it for this video.